Hello, I'm Moshumi. I'll be presenting our research, revisiting automatic evaluation of extractive summarization task. Can we do better than ROUGE? To begin, ROUGE is the most commonly used metric for evaluating text summarization. ROUGE considers direct lexical overlap to assess the model-generated summary with respect to a ground truth reference. Although ROUGE has been criticized for not being semantic aware, the majority of summarization models assessment till today are still based on ROUGE. In this work, we revisit the popular ROUGE metric exclusively in the context of evaluating extractive summarization. In extractive summarization, sentences are ranked from the original document according to how well they reflect the overall description. And then a summary is created by concatenating the top-ranked sentences. Till today, the heavily used technique to evaluate extractive summary has been to compare it with a human written reference with respect to ROUGE metric. If the human written summary includes more novel words than the original document, ROUGE will provide a poor score to extractive summaries due to a lack of semantic awareness. On the other hand, ROUGE metric was not originally proposed for evaluating the quality of a ranker. However, the heavily used technique for extractive summarization is ranking, hence this does not give a fair evaluation. To be fair, we believe the right evaluation metric for the extractive summarization task should also consider the quality of the sentence ranker with respect to a ground truth ranking while being semantic aware as well. If you remember, I said the right evaluation metric for the extractive summarization task should also consider the quality of the sentence ranker with respect to a ground truth ranking. Now, how can we create the ground truth ranking? One way can be is to ask human to rank sentences for the ground truth ranking, but manual ordering of sentences by annotators is costly and time consuming. Also, it's not feasible for large scale evaluation. This is why we opted for an automated way to create the ground truth gains without involving humans. To describe the pipeline, suppose there is a document and human written reference with a bunch of sentences. We convert the sentences to sentence embedding and then compute pairwise quotient similarity and average them. Document sentences are then ranked in a descending order and are given probabilistic gain. Now we have ground truth ranking and gains. Next, consider the document is passed to an extractive model. For top K ranked sentences for the model, we can compute the cumulative gain from ideal gains. When we divide this cumulative gain with ideal cumulative gain for top K sentences from ground truth ranking, we get Siemens-CG score. We have used Siemens-CG metric to assess 6 extractive summarization model. Also, as the core of Siemens-CG metric is sentence embedding, we have experimented with various sentence embedding to test the sensitivity and found Siemens-CG is robust across multiple sentence embedding. To test the semantic awareness of Siemens-CG metric, we have perturbed 20% of document words with synonym for CNN Daily Mail dataset. The figure shows that the ROUGE score highly varies, confirming that ROUGE is not semantic aware. Clearly, this is not desired from a good summary evaluation metric. Human reference may have different keywords from the original document. We have conducted the same experiment with Siemens-CG metric and found that Siemens-CG is more robust while the scores are almost similar. One interesting thing we observed, although ROUGE and Siemens-CG agree on relative performance of multiple summarization models, in the average case, the agreement does not hold for individual document samples. Here by disagreement, I mean, if we compare model A and B, when ROUGE is saying A is better, Siemens-CG is saying B is better, and vice versa. Here is in the figure, showing that conflicts between BERT versus DistilBERT and mobile BERT versus DistilBERT out of 11,426 samples. You can see there is almost 50% disagreements. We next took a deeper look into the cases where Siemens-CG disagreed with ROUGE. We asked humans to blindly evaluate the quality of the summaries generated by two models. When we matched their decision against both ROUGE and Siemens-CG's conclusion, blind evaluation by humans indicated Siemens-CG was more accurate than ROUGE. We further performed meta-evaluation of the Siemens-CG metric utilizing data provided by SumEval community. The dataset includes 252 summaries generated by extractive models. Each of these summaries were evaluated across coherence, consistency, fluency, and relevance dimension. Then we compute Kendall-Tau correlation with human judgment in the case of high overlapping reference, low overlapping reference, and medium overlapping reference. The figure shows that Siemens-CG is clearly a superior metric when evaluating summaries against a more abstract reference. Our metric doesn't perform well for fluency dimension, which is somewhat expected in extractive summarization. The figure also shows that our proposed metric outperformed ROUGE in terms of consistency, the most crucial dimension for all three types of reference with a considerable margin. To conclude, CMNCG is a superior metric when evaluating summaries against a more abstract reference, and also CMNCG correlates better with human judgment. As future direction, we want to incorporate redundancy while creating the ground truth ranking. We also want to enhance for multi-reference and multi-doc summarization. Thank you.